Hey guys, welcome to our first digital lesson. So today we're going to be talking about tree diagrams. Now, a tree diagram gets its name because all of these lines here that you can see that I'm drawing on now are called branches. So it's as though we are starting with like the root of our tree. So this is the trunk, and then it's branching out into a beautiful tree. So you'll see here that there's a very specific way that we're writing our tree diagram. Do you notice that everything kind of makes these lovely columns and everything across is also all lined up? This is really important when you are doing a tree diagram, and this is what would be expected of you in an assessment situation. So why do we have tree diagrams? Well, tree diagrams can be really useful when we have a lot of things that we're experimenting at the same time. So an example of what this tree diagram would be showing us is that the first thing that I did is flipped a coin and then I picked a marble out of the bag. You'll see here as well that there are some numbers listed on here. So these are the probabilities of the event occurring. Now, if it is even, so you can see here I have a 50-50 chance of getting heads or tails. You don't have to write the numbers, and you might see that in some of the examples that the numbers aren't written there when it is an equal chance of occurring. Sometimes it's also just good habit to keep them there. You can see in our marble pick that there's more red marbles than blue marbles, so we don't have an even split. This is where having your fraction is very important. After we've done our tree diagram, you can see that all of the outcomes are listed. So we can either have a heads and then a red marble, a heads and a blue marble, a tails and a red marble, a tails and a blue marble. And the probabilities are listed there as well. So all that we do to find the probabilities when it's in the tree diagram is we times everything together. So if we're following this first branch here, we start with the heads and then we pick a red marble. So a half times 3/4 equals 3/8. Let's keep following our tree here. We go through a half, we come down this branch here for a quarter, and we get 1/8. Let's continue going. We've done all of our heads branches. Let's go down to tails. We go down a half and 3/4. We get 3/8 again. You will find a lot of these probabilities repeat, particularly if there are some even chances in there. And that last one there, we follow that branch, and we've got our final one there. You'll also notice that all of our probabilities equal 1. So if I add 3/8 plus 1/8 plus 3/8 plus 1/8, they all equal 1. Let's go to the next page. Doing these examples in the opposite order. So we are going to start with example 3. And the reason why is because example 1 is actually a very big tree diagram. You might notice that sometimes we end up with a lot of branches. The final one has 18 outcomes. So let's start it a little bit smaller. And in this first example here, I want you to notice this tree diagram here. Now, one thing that I really want to stress about in this topic is that there are a few different ways that people might draw a tree diagram, but the way that I have showed you on the previous page is the expected way to do it on an assessment, whether that's the probability test, the end of term test, or the exam. So if we look at this, we look at this tree diagram here. One thing that I can notice straight away is that I don't have my beautiful even sections. It's not labeled. It's looking a little bit messy. The other thing that I have noticed is I don't have my outcomes or probabilities. So this one here is a big no. We don't want to be drawing like this. Let me show you how we should be drawing this tree diagram. So the tree part that they've done is correct. I should be seeing some branches that go off to other branches. Now this first section here, the first line that we see, this is the first game that was played. And in that first game, you can either win or lose. Now these probabilities are in decimals. That's not the end of the world. If it's already given to us in decimals, we can keep it that way. But usually we do prefer fractions. So can you see once again, this is all lined up. This is perfect. This is exactly what we want. The next part of this one, so you're playing two games. You're either going to win the first game, and then you can win or lose the second game. Same if you lose the first game, you can either win or lose the second game. And they also have varying probabilities. So because all these probabilities are very different, we're not going to have any similarities between our final answers, our final probabilities. They're all going to be very different from each other. From here, once you've drawn this part here, so this is looking a lot better already. From here, we then have our outcome section. So let's have a look. I can either, if I follow my tree, I can either win and then win again. And again, we're being lazy, just note them as the different letters, that's fine. You can either win or lose. You can either lose and then win, or you can lose 2 times. The final part to this is we need to write down our probabilities. I'm just going to write PR for short. So remember, if we're following that branch here, I've got 0.65 multiplied by 0.8. And that is going to give me 2 seconds, guys. I'm just going to do that on my calculator here. That gets me 0.52. So the way that I got that answer, I'm just going to do this over here. So I did 0.65 multiplied by 0.8. That is the probability of a win-win. Let's have a go at the next one here. So it's still going to be that 0.65, but now we're multiplying it by 0.2. So the probability that we win a game and then lose the second game is 0.13. And all we have to do now is continue that down. So 0.35 times 0.45 is 0.1575. Let's do the next one. 0.35 multiplied by 0.55 is 0.1925. So this is what our tree diagram should look like. Now you don't need the yellow part there, so I'll get rid of that. And it doesn't have to all be in different colors like mine. It can be the one color. But again, look at these clear, even lines. If I'm looking across, I can clearly see the ends of those branches are lining up perfectly there. I can also see my columns as well. These are all lining up. So it's evenly spaced. We've done all of our columns. This is a 4-mark question. Now, one thing that I told one of my classes is that if you are ever given a tree diagram question, because they can take such a long time to draw, it is usually recommended to leave any tree diagram questions till last. This is worth 4 marks, therefore it should take us around 4 minutes to do so. If we have a really big tree diagram, like we will when we go back to example 1, you will see that it can take a really long time. So leave it till last if you can. Let's go to the next one. So this will be a typical example that you will see on an assessment is we'll be giving you some information and your job will be to draw the tree diagram and then tell us a little bit about the tree diagram. So very important as always to get that highlighter out and highlight keywords here. So I can see here that we guess the answers to 3 true or false questions. Now, true or false is a bit of a clue. If something is true or false and you're guessing it, that means that you have a 50-50 chance or a half chance of getting your question correct. So that's going to help us when we draw our tree diagram. So we have 3 different chances to guess true or false. So we are going to label our 3 columns. So we're going to have question 1, question 2, and question 3. Rule of thumb when you are drawing tree diagrams, your labels are fine where they are, keep them at the top of the page, but start your tree diagram in the middle of the page that you have available because these are going to get very big very quickly and you'll see in a second. So question 1, I start question 1, I either get the answer correct or incorrect. Question 2, I give it another chance. I either get it correct or incorrect. Same with if I get it wrong, I can get it correct or incorrect. Question 3, we try again. And look at all these branches. See, I'm already running out of space here. So we either get it correct, incorrect, correct, incorrect. You'll notice that every time I do this, I'm always drawing it the same way as well. So I'm always saying correct and incorrect. It'll be really helpful as well because sometimes you'll start to recognize there's a bit of a pattern that's occurring. So let's have a look at the probabilities for each of these. So we've said that the probability of just randomly guessing, you got a 50-50 chance of getting it right or 1/2. Now, as I said earlier, if it is evenly weighted, you don't need to write the probabilities. I still like to though, even though it might be a little bit more time consuming. I just find it better because then I know that I'm doing the right thing. So you can just write these just on top or at the bottom of it. Now we're not done just yet. The next thing that we need to do is list all of our outcomes. Oh. Now my possible outcomes. Let's follow that line across. I could get all 3 correct. I could get 2 and across. I could get a tick, across, and a tick. A tick, across, and across. Now look at how I'm doing this as well. If I was to follow a random pattern, you can see that that evens out there. So make sure that you're lining these up. Same if I was to follow a different path, that's still lining up really well. So let's rub that out. Let's finish off this tree diagram. My next one that I have here is a cross, tick, tick, cross, tick, cross, 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 tick, or cross, cross, cross. Now, because these are all evenly distributed, the probability for all of these is going to be 1/8. Now, the way that I got that number is, so remember, let's follow that line just so we can see it. We'll do it for the first one. So when we got this example, we want to go, oh, that's the wrong one. 1/2 times 1/2 times 1/2 equals 1/8. So all of these are going to be 1/8. They are all evenly distributed. Therefore, I don't have a pretty equal chance. I do have an equal chance that they are all going to be correct. Now you'll see here that I did the working out for one of them and then just wrote the rest of them, that's completely fine. I would still give this 1 mark because you've recognized that they are all going to be the same. Now let's actually answer some questions about this. So determine the probability that your friends got all 3 answers correct. So what I am going to do is I'm going to find that outcome on the side here. All 3 correct? Well, there was only one option for that, which was this first one here. And we had a 1 in 8 chance of getting that right. Let's have a look at the next one here. Got 2 answers correct. Now, I'm going to assume that this is exactly 2 questions. So let's have a look through and see where we had 2. We had 1 there, 1 there, 1 there, and that's it. So what I'm going to do now, I know that there were 3 options where I had 2 that were correct. So to find out what the probability of this one would be, oh, what happened to my color? I wanted blue. So the probability of 2 correct, I'm just going to do a tick, that's going to be easier, is going to be an 1/8 plus an 1/8 plus an 1/8, which equals 3/8. So it's a little bit of a tricky one here because you'll notice that we were doing a lot of timesing of probabilities, but now we're adding them together. So it's really important that when you are actually answering questions about it, you've already found the likelihood of each favorable outcome occurring. So all you have to do is just find where that favorable outcomes are true. This last one here, we've got no correct answers. How often? Why did that go blue? I don't want blue. So where does that occur? That only occurs 1 time, which was also the 1 in 8. Hopefully this is starting to make a little bit more sense. Let's have a look at this final one here and see how we go. For this final question here, I actually want you guys to have a go at this on your own. I'm going to get you started though, but I'm going to run out of room. As I said earlier, there's going to be 18 outcomes. So that means that I need to have 18 rows that are going to fit along the page. I'm going to run out of room very quickly on my tiny PowerPoint here. So make sure in your booklet you have the whole page to do so. Make sure you're starting in the middle of that page and then branching outward. You're going to have to give yourself a lot of space. You're really going to have to extend those arms like this. Now, as I said, I'm going to give you some tricks and some pointers to get you started. For this question here, we know that the first thing that we were going to do was roll the dice. Now you know that there are 6 possible outcomes to that. 3, 4, 5, 6. So you should have 6 branches that are a lot neater than mine. But I just want to do this so that you can see what the options are. Now off this, we also have our spinner. How many colours can you see on the spinner? There's red, yellow, or blue. I'm just going to do it off the number 3 for now, but you will have these options coming off every single dice roll. So you're going to have red, yellow, and blue. Let's check what those probabilities were. The probabilities of rolling a dice is even. So there's a 1 in 6 chance of this occurring for all of these outcomes. Again, you don't have to write the 1 in 6 there, but I find it just a really good habit anyway. For our spinner here, we can see that this spinner is not even. So there are 6 total slices. So all of these will be out of 6. We need to figure out how many of each we have. So we have 3 of the reds, we have 2 yellows, and 1 blue. So again, I'm just going to go off this one here that I've made. So I'm only going to have 3 outcomes here just to show you that example, but you're going to have all 18 when you do yours. So in this example here, when I roll a 3, I can either have 3 red, 3 yellow, or 3 blue. The probability of those occurring, we have a 1 in 6 by 3 in 6 chance, which is a 3 over 36. We then have a 1 in 6 times 2 over 6, which is a 2 over 36 chance. And we have a 1 in 6 times 1 in 6 chance, which is a 1 over 36. Now, some of these fractions you could simplify. This would actually be a question where having all of your probabilities ends in the same denominator would be really helpful, particularly when you start answering some of these questions over here. So I'll make sure that this solution is available for you. So your job is to continue on expanding all of these with all the options. You'll see that these probabilities as well do repeat. So as I said, when you do have an even event that is occurring against one that is biased, you'll find that these numbers continue. So these probabilities will continue whether you've got 1 red, 1 yellow, 1 blue, 2 red, 2 yellow, 2 blue. These will actually repeat themselves. So give that one a go. I will make that solution available for you. And if you have any further questions, please reach out.